Okay, so this should be working now. Apparently, YouTube's setting up streaming is really awkward, so apologies for the 10-minute delay. So today I'm going to be going over a ton of stuff about building Flatpaks, from how you get started, just like going over how it works, and a lot of stuff about building. Someone in the chat asked about host commands. I will also be covering host commands. And let me just make sure to set up. It should be. Can everyone hear me now? Okay, great. Do note that there's a slight delay between the stream appearing and the motions I make. So yeah. Okay, so there's going to be a bunch of things we'll be going over. I will say that you should be decently comfortable with the terminal. You don't have to be 100% on it, but at least somewhat familiar with how it works. And then we'll get to building some Flatpaks. So, start with some terminology. Everything inside a Flatpak is stored in an OS tree repository. And I'm going to explain that in a moment. But that's basically where all the blob files are stored. And then we have this concept of runtimes. It's a collection of common libraries that most apps will depend on, that a bunch of apps need. And so they're set apart in a separate runtime that different Flatpaks can use. And you'll see two different terms used to refer to runtimes. A platform, this is just basically like a normal runtime. You may have seen it before, org.freedesktop.platform, org.gnome.platform. They're just different runtimes contain some common shared libraries. org.gnome.platform, org.kde.platform. Those have extra libraries for GNOME apps and KDE apps. And we have an SDK, usually used for building your apps. It's just a runtime with a bunch of development files, development libraries, development programs. And some apps may also use this as their only runtime. So if we hop over, we can look at, say, Visual Studio Code. And you can see it uses the SDK as its runtime. And that's because from inside it, I will explain this further later on, we can access different compilation commands and such. They're only in the SDKs. So that's just I just realized I made a typo here. These should both be SDK. But that's just a big overview of some terminology, and then we have the idea of an ID. It's just a unique identifier for your app. You've probably seen them dozens of times. It's domain tld dot something dot something. Okay, OS tree repositories. I like to think of them as Git for operating systems. And everything you have in Flatpak is stored in one of these OS tree repositories. Let me just merge these two workspaces. Smarter, not harder. So we can see here, this is the system installation OS tree repository. And basically, everything inside of Flatpak is stored in one of these two repositories. And we can see some of the individual items inside in the objects folder. They're sorted by their SHA-256 hashes. And basically every file you have is just stored here based on its hash. It doesn't matter where it comes from or whatever the path. Files are stored as objects. Directories are stored as objects. And directory metadata are stored as objects. And it's all just stored in this giant repository. And then we have a concept. This should be commits, oh my gosh. But we have a concept of refs. And let me run this sec. A ref is just like a branch is basically a name that points to some set of commits. So, refs are used in Flatpak. You may have seen the term ref before when you might be running Flatpak install on older versions and it would say, oh, do you want to install this ref? That's actually just referring to these OS tree refs. Each one of these points to a commit, and I can use my Wayland gestures because this is Xorg. A commit is a set bunch of changes, basically. A ref points to a commit. So we might have, let's do a concrete example. GNOME SDK. This ref is just a name for a commit. We can actually see it. Ref slash, what was that? Let's do head slash deploy slash runtime org.gnome.sdk. And then we can see there's just a bunch of text files and points to a commit. And what this is basically saying is at this commit, this will contain the state of whatever we have installed. And also, just as a side note, I will be taking any questions. If you have any questions during the course of this, just feel free to put them in the live chat. So basically, we have these commits. And when we have these, right, if you look in the Flatpak folder, we have... I don't think I have that installed anymore. Let's do... I don't know. We have this file system tree that appears to contain our app's file system, right? This is actually just a bunch of hard links that point into the actual objects in the OS tree repository. And this is actually really important and interesting because all files with identical contents have one on-disk copy. So, they all, like I said, they all have one on-disk copy, so we can have the same file 10 times. Was checked into a repository, they all have the same hash. So it'll be stored as the same object. Let me go over here again. They will be stored as the same object, and then a hard link tree is created for each of the individual apps pointing to these objects. And this is very powerful. You'll see in some Flatpak apps. If you look at manifest, say it needs the .NET runtime files, it'll literally just copy it over. Because if you have two apps that use the same .NET runtime files, the copies will be deduplicated. And again, I mentioned this here, checks into files. When you create a new Flatpak app, checks them in, again, Git terminology, stored it as a ref pointing to this commit, and this commit is just a change where you added all the stuff in. Then Flatpak on the user system does a pull, pulls the commit, and checks out a tree of hard links. And again, this was just I have a bunch of example commands in the slides that will be uploaded later. So for anyone who's following along afterwards, you can even copy and paste stuff if you want, I guess. And here's a quick overview of names. You can see a few of these, right? From the output of OS tree refs, we have app slash runtime slash, by mostly referring to this part. org.gnome.sdk slash x8664 slash master. So first off, we have the app ID, again, that's just a unique ID. Afterwards comes the architecture, which is just, again, I've got some examples here of potential architectures. And then we have a branch, which is usually used for versioning. So for instance, the free desktop platform, the current version is 18.08. It uses Calver, which is calendar versioning, released in August of 2018. And different apps can use these different branches to separate their versions. So, I mean, I'm not actually sure if I have any installed that have this, unfortunately. Any of these are nightlies? I don't think so. Or this one. Flatpak info. Yes, see, we can see the branch here is master. But if we did, and master is usually used to refer to the results of building nightly apps. And then we can have, let's look at VLC. And this one, the branch is stable. So branches are basically just a way of separating different versions. Again, completely unrelated to Git branches. Git branches are like OS tree refs. This is a different concept. And you can also use some shorthand for it. If there's only one version installed, you can omit the architecture. or you can omit the branch if there's only one branch installed, but include the architecture. You'll see this double slash notation a lot, which is why I put it here, because it's handy to know. This is basically saying, oh, we want to use org.gnome.photos stable branch, but I mean, I only have one architecture available, so just figure it out, Flatpak. And a lot of you probably know about Flatpak, everything is sandboxed. And all this information is stored in the metadata. So we can see some metadata for an app, and this is basically a giant INI file, and it specifies a bunch of information about the app. Let me see, I should pipe down to that. No, that didn't work. Okay. I was hoping I would get syntax highlighting. But we can see there's the application name, the runtime it depends on, the SDK, the command that Flatpak will run when it runs the application. I'll explain the permissions soon, but you can see all the permissions are specified here. This is saying that, oh, it has shared networking, shared process communication, can access Xorg, Wayland, Pulse Audio. These file systems, that's just for dconf storage. It can access your home directory. It can talk to these bus names. These are environment variables that are set. Extensions I will again explain later. Basically, all this stuff is stored in the metadata. That's really what is important to remember. It will be handy very soon. So when you're inside of Flatpak, let's go inside the fractal Flatpak. And this thing that I'm doing, dash command equals bash, I'll explain that in a moment. But we can see an example of the file system tree. So in /usr, that's the user. You may know it as having all your applications and stuff on your system. In the Flatpak world, that only contains the runtime or SDK binaries. So you can see in here we have all the different binaries that are part of our runtimes, quite a few things. I don't even know why mount is in there. You can't even use it really, as far as I know. But you have quite a few things in there, but that's not where your app actually is. Your app files are stored in /app. That distinction is made just to make things a little neater, makes it easier to use. And we can see inside app/bin, we have fractal. In share, we will have our just various stuff, the desktop file and such. It's all stored under app. Usually when you're building stuff inside of Flatpak, you'll use /app as your prefix. And one important thing to note, /usr is read-only because that's checked out from the runtime. Like I said, it's a hard link tree. You can't really easily modify it. And once your app is built, that's also read-only. So right now, if I'm like, oh, touch /app/x, read-only file system. /app/extra, I'll explain that a little more later when I get sources, allows you to download proprietary files, right? Because some things have non-redistribution clauses, Unity Hub, things like that. And you can't legally redistribute it, but what you can do is just upload a really small Flatpak to server. When the user downloads it, it will download this non-redistributable data on the user's end. That will be stored in /app/extra. I'll explain that more later. /run/tmp, they're both tmpfs's, entirely sandboxed and separate from the host file system. And one thing to note, all your XDG directories, which is where your apps will usually store stuff, are all separated. So if we go my host file system, I can see in /var/app, I have a bunch of different apps installed. If I look at, say, Discord, these are all our XDG directories. Instead of .config, which is the normal one, inside the Flatpak, it'll be var/app/appid/config. Same thing for the data home and catch home. And they're all aliased as var/var/data, /var/config, /var/catch. Basically, just keeps your files a lot neater, easier to work with, more organized. Now we start getting to building, finally. So this isn't how you'll normally build Flatpaks. This is the lower level way, but it's really handy to know this because everything else depends on this. And it's a series of commands that begin with Flatpak build. Flatpak build init will initialize a build directory. Inside this build directory, a built root file system, a built/app, will be stored. And we pass our app ID, the SDK we want to use, the runtime we want to use. If I were to create one right now, let's tst, and I already have some stuff there. Create a new directory. We can use Flatpak build init, and I might already have this in my history. This will be our build directory. Our app's name will be com.my.app. Free Desktop SDK is our SDK. Free Desktop Platform is our platform. And now my build will contain in my build/files will be whatever we have in /app. So all this stuff will be stored here. Flatpak build will run a command inside the build directory. You can install things into it and such. Flatpak build finish will tidy everything up, write the metadata. I'll get to that in a moment. Let me jump back a bit. I thought I had this written out. So say we were here, right? We ran Flatpak build init to create a build directory. I can run Flatpak build my build echo 123 to print this command is being run inside, and we can actually see that. We can ls/app, and that's empty right now, right? So say again, Flatpak build just runs a command inside of a sandbox in your build directory. Say we touch /app/x. Now it's in my build/files, and then Flatpak build finish finalizes the build correctly and writes the metadata file. Remember this metadata file with all our permissions and stuff, that's written by Flatpak build finish, and we can actually see Flatpak build finish -- help. These are all sorts of permissions we can use, and that's all handled by build finish. So again, this is just an overview. I have some links in this presentation, so when I upload it, you'll be able to click them. This just takes you to the Flatpak docs, and yeah. Hold on, one sec. I should probably close all this before. This is fun. This is very fun. Clicking that link totally wasn't a bad idea. Here we go. Okay. That was awkward. So we can pass some different metadata to build finish. Some of the permissions, again, you can see them right here. One of them is --allow. --allow equals devil will allow you to use certain syscalls like ptrace. They're not normally allowed. Normally, you're not going to add this unless you're building an IDE, or you can run Flatpak Run in a special way, which will enable this. We'll get to that later. A really interesting one is --allow equals multi-arch, which lets you run binaries for other architectures. Say it's x64, you can run x86 binaries. That will be explained a bit more later again. You can expose some file systems into Sandbox, and you can own dbus names and talk to dbus names. This is actually really handy for a concept called portals, which we will get to really soon. And in this file system argument, we can pass a bunch of special stuff. We can pass an absolute path. This will make this path available from within our app. We can pass just a word -- file system equals home, which will share the home directory. We can add a subdirectory to that to just say, oh, share this path relative to the home directory, but not the entire home directory. We can share our entire host file system. Now, there's some gotchas to this. I'll get to that in a moment. But we'll basically add your home directory. We'll also add several host directories under /run/hosts. We can share some different XDG directories, desktop directory, documents, download, music, pictures. So for instance, say we run something, when you try and run SDK, open the shell inside, it has no permissions. We can't see our home directory. This is what appears to be our home directory. It's just empty. But we can add some permissions to that. We can pass permissions to run. Let's do -- file system equals desktop. CD desktop. Oh, look, the desktop directory is exposed and it's empty because I have a nice and clean GNOME desktop. But that's the idea. You can also share subdirectories of your XCG run, which is /run/user/the-uid. So if I look here, I can see, say I want to share this libpod subdirectory. I would do --file system run/libpod, and then libpod is now exposed inside. And one thing I didn't cover is that much, but these permissions, you can run an app with a permission just once by passing it to Flatpak Run. If you pass it to build finish, again, it finalizes it in a build directory, but Flatpak Run is just entirely temporary. And I'm still trying to use these nice Wayland gestures that unfortunately don't work here. This gets me to one of the really powerful concepts of Flatpak, which is a portal. Here's our example, right? Writing a chat app. You shouldn't need to access the whole home file system if you want to attach a file. You just want to open a file dialog so the user can add a file. You don't need access to the home file system for that. So there's this idea of portals, which is having a dbus API that lets an app ask it for information. So I have some links here. Let me open this in a new window this time. So we can see this is the SCG desktop portal docs. These are all APIs that we can call into. I mean, not all of these, but almost all of them. That we can call into from inside our Flatpak apps to do stuff. We can use the file chooser portal and call these dbus methods to open a file, have an open file dialog, have a save file dialog. And then they'll return a path that has been exposed inside of the sandbox, and mentions it here. We made accessible to application as a subpath in one of these directories. And you normally don't have to use these directly. For instance, GTK inside Flatpak will automatically use the file chooser portal if you use GTK file chooser native. Calling XCG open will use the open URI portal automatically. For instance, let's just try this. Let's open up a shell inside the Flatpak portal, XCG open, google.com. Let's do it so this is our window. Opens google.com. Now this actually called into the OpenURI dbus method, but it was all implicit. You don't have to worry about it. Now this is something that one person in chat requested, which luckily enough I was already planning on talking about, which is calling host or sandbox commands. And what was the exact question? Like stuff like VTE terminal. That's a little more complicated. I will cover that a little later on. But at a glance, sometimes you need to run a command in its own sandbox, right? We might want some sandboxing inside of the sandbox on the host. And there's a nice little tool called Flatpak Spawn that covers that. And we can access the portals by using Flatpak Spawn-sandbox, which will contact this dbus address and open, and this is all transparent, so this will open it's just trying to cheat share into a directory it doesn't have access to. But this will open a sandbox version of this of whatever command we do it, completely sandbox, completely separate file system. We can expose some file systems into it, but by default it has access to none. And then we can run host commands. This is the more interesting one. Now this is important. We need to add this permission because it's not possible by default. You don't want all your Flatpaks to be able to do this out of the box. But we can pass --talk name. This is the dbus interface. Oh, I actually opened Fractal. Forgot to leave the shell command on there. This runs ls/ on the host, and you can see the output matches up. That runs a generic host command. And now if you're writing a terminal emulator, I will say it is a little more complicated. I kind of want to make a library that wraps libvte with a libvte-like interface that has everything sandboxed. I believe there's some code in Tilix that calls the dbus APIs manually. The one you would want, I don't think it's documented here. let me head over here a sec. And let me see if I remember where this is. I have some stuff to tilexes, but I kept running into some random memory corruption issues, which are probably a bug in GTKD's dbus bindings. And it was kind of complicated, not something I want to spend that much time on. Should be here. Yes, so you can see here that inside of the Flatpak environment, it creates a PTY, sets everything up like normal, but then it basically ends up calling this function, which will manually call the Flatpak spawn. See, or this is the dbus name, org.freedesktop.flatpak. This is the interface. This is the object. That's the signal subscribe. It objects interface. It calls the host command function, passing all this stuff over. You can, I believe GNOME Builder also does this off the top of my head. I can't remember inside the source where it does. Oh, someone said terminal.d is what you're looking for. Thank you. But in GNOME Builder has an example of this that doesn't exhibit random memory corruption, which is not a very good thing, but this is a rough idea of how this would work if you're writing a terminal emulator inside Flatpak. If you want, I can actually look that up a sec, but I don't know the exact file off the top of my head. Actually, you know what? I have GNOME Builder source code here. I can just look at it myself. This is a couple, months old source code. Let's look for host command. Oh, look, here's the file, IDE breakout subprocess.c. Lib IDE/subprocess breakout. And you can see it's basically doing the same thing, sets up some output streams, the std handles, the flags for where std out and stuff will go. Let me scroll up a bit. Yeah, this is just a generic subprocess wrapper. And then this is where it actually calls the host command method. And again, you can forward any file descriptors -forward fd to this, and that's what this does. It forwards the file descriptors for std in, std out, std that are pointing into a PTY allocate. I don't know if it actually does the PTY allocation right here. No, it doesn't. But that's basically how it would work. So for whoever is asking, that's roughly how it would work. I really need to pick up that Tilex Flatpak again, but building B, Lang unfortunately broke. And here's the build example that apparently mixed up the slide order. This is basically what we did. This does show that we can actually just write files into the build directory without using Flatpak build. We can try this on the host. Am I still in? I'm not in that directory still. Let's mkr-p. We just wrote a file inside our build directory. Now it's there, as you can see. And we can use chmod from inside, just as an example. Now it has executable permission. And then we could use build finish now. I forgot the directory. And all that's written, and we can actually look at the metadata file. And there's not very many permissions, I just exposed home. But that's how that would work. I also don't know why Prism.js. Oh, that's because it was selected. So, I'm not going to cover hosting your own Flatpak repo, because that's a lot of everything. You can see there's documentation on publishing, a ton of stuff. But TLDR of it, Flatpak build export will take our build directory that we wrote here, my build, and export it into an OS tree repo. And it'll create the repo if necessary. Build bundle will take a repo and take an app and generate a bundle file that can be installed standalone. And then you can also import bundles into your repo. And here's an example. Again, these commands should work here, so we can just export it to my repo. My repo now contains, you can see this in OS tree repository. Let's see what some of these objects are. We can see all our compressed objects here. And then we can build a bundle from it. We can build a bundle from it, and now this route con.my.app.flatpak. This is our Flatpak bundle. If I could make GNOME software work, you could double click it to install, or you can install it from the command line via Flatpak install. And we'll install into user installation because I'm running really low on disk space on my system partition. There's nothing to import because I already installed it once. And then we can run it. And if you recall, in our my build, we just wrote, this just runs ls. In our metadata, when we ran build finish, we just said our command was my app, which is the shell script they called ls. So this is basically a glorified ls wrapper. We can pass all our arguments to it and such. And now, I kind of mentioned this a bit ago, but Flatpak Run you can pass permissions to it. You can open a shell inside. And you can't access the host file system normally, like, right, this exists on my host system, RPM OS tree stuff. If I try an ls, let's leave that stuff on there. RPM OS tree, well, it doesn't exist inside the Flatpak, because Flatpaks are sandboxed. And if I expose the host file system, like I said, there was a gimmick to this, well, it still doesn't exist there either, because the host file system is mounted under /run/hosts. So if we pass file system equals host, then we can find the host files, but they're mounted at /run/hosts, not the actual rootfs. This is just to avoid weird conflicts, right? Because if everything in /user/lib were mounted on the same path inside the Flatpak, there would be a lot of conflicts and such. And again, we can run a custom command, so we can, for instance, use it to open a shell. We can run the app in development mode. By that I mean, if we open a normal shell into com.my.app, so we try to use that doesn't exist. But basically, if we tried to use stuff like ptrace, it's not going to work because it's sandbox. It's on the syscall blacklist. But if we pass -d to it, that's the same as passing -allow equals devil. And then it also uses the SDK as our runtime. So now we have access to GDB, and we could actually GDB ls and stuff like that, and it'll all work. This is really handy for debugging. You can use it to also strace stuff. Now, and these next couple slides should go a lot faster, we're going to go into some higher level building. Flatpak Builder. You've probably seen this tool before. It reads an input manifest file in JSON or YAML. For a long time it was JSON only. YAML was added a bit more recently. I don't remember how long ago. But Flatpak Builder basically takes this build directory, like we create ourselves, a build manifest, and it runs a bunch of steps inside the manifest to build it automatically. Here's an example of a manifest file in YAML syntax. We would set our app ID, the runtime version. Quotes are important because this is YAML, and it'll think this is a number 18.08, not what we want. We pass our SDK as the SDK argument. Finish args. These are arguments passed to build finish. If you recall, that's how we set our permissions. So in Flatpak Builder, you would set your permissions under finish args. And then modules contains a sequence of build steps, basically, that should be completed. Modules are how it logically separates build steps. We can see here we have a module named my app. Modules is a list. You can see module. If you're not familiar with YAML syntax, quick primer. This is how we set keys and values. Does giving host permission mean I could run dev tools in my system from a Flatpak? So actually, yes. Again, it's really delayed, so you may not see this immediately, but it actually does. I don't know if I have any development tools as an example installed. Say I want to run, well, you know what, I could run GJS, yeah. So say I want to run, your example was PHP so as a side note, there is a .NET Core SDK extension. I'm going to go over that in a moment. But we could, let me just, oh, we won't actually, that would be nice to have. Talk name display free desktop Flatpak import. We could access .NET from inside via its own SDK extension. Again, I'll get to those in a moment, or a little later. But we can spawn whatever host commands we want. Say, we don't have GCC, let's just pretend GJS is GCC. Because GJS isn't only available, for an example, but I can spawn hosts GJS, ta-da, it's there. Or, this is GJS, not node. There we go, we can spawn, I think, yeah, that's not going to work. Let's try this. Yeah, we can, I have a container helper that has node inside, we can run whatever, we can spawn node from there. Actually, if we open Visual Studio Code, let's hope this doesn't take too long to open. You can override permissions. Let's just show, which will add extra permissions to an app that were normally there. I think do I not have? Or does it already have it? I think it actually already has its permissions. You don't need to override anything. Yeah, you can already run Flatpak spawn from inside VS Code. I want to make an extension that will automatically kind of set some stuff up so you don't need to manually do all this for Flatpak VS Code. But you can access the outside world. For debuggers, it would be a bit more difficult. I know with Unity Hub Flatpak, I mean, that's Unity Hub's own fault. It uses Unity's PID to try and find a port the debugger stuff is listing on. So I had to wire that all in a really weird way. But for most cases, it shouldn't be that difficult. You would basically Flatpak spawn it. So yes, basically. Yes, you can. So, modules, how it logically separates build steps. Oh, I was doing the little JSON primer, right? So basically, we can YAML, we can specify keys and values. This is like, if you're familiar with JSON, it would be like this. These are equivalent. And then when we specify a modules list with stuff like this, that's equivalent to just this JSON. So basically the dashes mean, oh, this is a list. And then if we have key colon value, it's basically automatically creates an object for us. That's the gist of it. Okay, back here. This shows a module. This is basically a build step. Our name is my app. Build system is simple. I'm going to go over this all in a moment, but this should be what it roughly looks like. Now, the build system argument. Here we can see we said build system is simple. Build system determines how this application will be built. If we say build system is simple, it doesn't do anything special. It just runs everything in build commands. If we say build system is auto tools, this is the default, if not specified. It'll automatically run configure, and it'll run make, and it'll run make install. So if we had this module, again, this is the default, so if you don't see build system specified, this is automatic. Build system auto tools all automatically run configure, make install with the correct prefix, correct arguments. All of it is set up automatically. And if the configure script doesn't exist, it'll automatically call autogen. There's a CMake build system, which just runs CMake. Again, everything's set up automatically. CMake Ninja, which uses Ninja instead, basically gives you much faster builds, but not everything supports it. Most build scripts should. The Meson build system, a lot of GNOME apps use this now. We can actually see this in... Again, I have a really old version of Builder checked out. We can see this in builders. This one is JSON format. What am I looking for? Build system Meson. Like when it's building libgit to glib, it says build system to Meson, and this will automatically use the Meson build system, pass all the correct arguments. There's another option here that's interesting called builder true, which basically just builds it in a separate directory. So instead of, say, CMake, instead of just calling CMake dots and doing everything in the same directory, it would mkdir build, cd build, CMake dot dot. If you're not familiar with CMake, that may seem like garbage, just what is going on, just ignore it then. And of course we can run qmake. I guess Qt and KDE apps use it, but qmake is terrible anyway. And we can pass some different build options. You already saw build commands, right? Up in this slide. Build commands runs this command. Build commands is a list of commands to run during the build. For build system simple, this is just our whole build. Because build system simple means don't do any magic. If we have any of the others like CMake or auto tools, it runs it between the build and install steps. So say with auto tools. Between make and make install, it would run whatever's in build commands. We can also, for all of these except simple, use these options, config ops, make args, make install args, which would look kind of like this. Config ops -- enable foo make install args emit something equals 1. And these are basically list of arguments that will be passed to configure for config ops. For make args, it's make install args, passed to make install. If you have Ninja, then these will be passed to Ninja and Ninja install. For CMake, Meson, QMake, config ops will be passed to whatever is the configuration step. ARM configure, this one's kind of interesting. If you recall, it'll automatically run autogen if the configure script doesn't exist. ARM configure means that it just always runs autogen. It deletes the configure script, reruns autogen each time. Post install means that we can run whatever commands we want after the installation. So after the whole build is complete and all this is run, we can be like, oh, let me change the permissions on this file, and, well, deleting isn't going to be that useful because we'll see why in a moment. Set up some sort of symlink or whatever. And then we also have the build options argument, which lets us store some more build options. Now, build options is interesting. Let me set an app ID here so this looks more like an actual manifest. Because we can also pass this at the global level. So we can say build options, and we can specify any of these, and they will be applied to all the modules. And then we can also specify them on the per module level. So some of the things we can set C flags, CPP flags, LD flags. The ones ending with override, the only difference is that, say here we set build options, C flags dash F, what would be one? F fast math. And then here we can use C flags. If we use normal C flags and say dash W no parentheses, I think that's one with clang or something like that. Say we pass this, or these are actually lists, sorry. Say it would look like this. We pass this here, these will be merged. If we use C flags override, it will completely clear this out and just keep this. That's the only difference between the override and the normal ones. We can set an installation prefix done automatically by default. Append path, all of these are kind of interesting. You can append things to your path. I can say, oh, the Golang SDK's bin, well, that's not too useful, Golang. .NET SDK's bin folder is in my path for every single module. We can also prepend instead. All of these should be rather self-explanatory at a glance. Environment variables is also interesting. We can say stuff like, oh, for this whole build, we want to set the environment variable don't delete, or no delete data to 12359 or whatever. And these will be basically environment variables set during the build. And config ops, make install args, all this stuff can be passed here as well. So it applies to everything. Not that useful to use at the global level, because if we have like an auto tools and then we have a CMake, the config ops syntax is going to be different. So I've never found that to be that useful. But this is an example. Again, we can have our config ops. We use CMake Ninja in this example. We can post install, set some C flags, append to the path, and build options, and some environment variables. Sources. This is the second big pillar in the syntax. So if you notice in our first example, I'm going to copy this out of here a sec. I need to, man, that indentation is all screwed up. This happens when you try and copy code from PDF. This all goes here. And we'll just say that's a different module. Okay, so in this example, we had some sources. These are the source files, right? Because we can build stuff, but by default, builds in an empty directory. There's nothing to build. It's not that interesting. So there's a bunch of this back to build, blah, blah, blah. Okay, manifest sources. The type option here, and again, if this were JSON, it would look kind of like this. Sources, type, script, name, my app. So this type here says the type of source it is. There are a bunch of different types of sources. I'm not going to go over all of these, mostly not these two, because I really have never seen a Flatpak that uses Bazaar. There's probably at least one, but really no one cares about Bazaar. So there are a bunch of different sources we can use, and there's some common options we can have on different source options. On different sources, we can say, oh, skip, these architectures are only for these architectures. That's really useful for some platform-specific binaries. I will get some examples of that later. And we can say the destination directory the source will go into. And say we're downloading a binary that's x64 only, we can say, oh, only download this source on x86-64. There's actually a real-world example of that I'll show in a moment. Archive sources, downloads, and and one thing I mentioned here, for any source that use URLs, you'll see them in a moment, you have to pass a checksum using the SHA-256, SHA-512 options, otherwise it won't work. Okay. Archive sources. You're going to use this one a lot. This is the one you're going to use almost all the time. So they just download an archive file and extract it automatically. We have the path or URL, either a local path or URL to remote files to download. Strip components will strip that many components from it, so I don't... Just basically, if you're familiar with a lot of these archives, the files will be of the format something like my, say my app 0.1 slash readme, my app 0.1 slash src slash xs. So we have this common component that we don't care about when extracting. We just want this. So strip components says how many components to strip from the paths, and it defaults to 1. So by default, this will be stripped. Now that does mean if there is no root directory, if you just have like readme src slash x.c, everything one level deep will end up in the same directory, not what you want. So it's important to note the option exists, but usually it does what you want it to. We can set the destination file name. Default name is URL space name. Like we can see here, this is our URL in this example, so this is the default destination file name. Extract it automatically, strip the first prefix, and because it's a URL, we have to specify a hash. And there's a real-world example of this, .NET SDK. We can see on x64, it downloads 64-bit binary, 64-bit archive, specifies an SHA sum. Use a simple build system, just copies everything over to SDK directory. This is the Archer version, this is the ARM version. Git sources, pretty simple. You pass a path to a local Git repository or URL. You can specify branch, a tag, or a commit to check out, otherwise it just does master. You usually don't want that because Flatpak Builder is really big on reproducibility. But we can disable shallow clones. Again, you're almost never going to use that. This is the type of stuff you're going to see most of the time. Type git, a URL, and then it specifies a tag or a branch or a commit to use. There are file sources. These are actually really interesting. You can use a local directory or a local or remote file. You can't use a remote directory because the protocols don't work like that. But we can say a local or remote path to the file or directory, URL is file only. A destination file name if it's a file. Obviously, it doesn't work on directories. we can specify a list of paths to skip, so we could be like type dir path my sources, and then we could specify some paths that should be skipped when copying the directory into our build directory. This should be mentioned. Oh my gosh, the typos. But we can dest, I had mentioned previously. We'll set the destination directory the source will go into. For dir source, it actually sets the target name of the copy directory. So if we copy, say, the src directory, we set dest to my src, this will be named this. And then for files, we can download a URL. Again, if it's URL, we have to have a hash. And then we can specify destination file name. Script and shell sources here are actually really interesting. You can see one in action here. Basically, they just write a script with this name containing these commands. So in this example, type script commands is echo123. Destination file name is this. This will basically create a file that contains something like bash. It will contain something to the effect of /bin/bash echo123. If we had another line with echo 456, that would also be part of the script. Save it, it'll save it there, automatically make it executable, then we can use it. We can also see that in, I don't know why I closed that, that was still useful, .NET SDK. Here it creates a script named install sdk.sh that runs these commands, and then this script is saved as a source so we can access it from our build commands, which is accessed here. And then the shell one, basically similar, but it actually runs the commands as part of the build, or as part of the source extraction process. Before the build begins, it's going right. It goes through each source one at a time. Oh, let me process this source, and when it gets to a shell source, it just straight up runs these commands inside the build directory. And then I believe this is one of the last ones here. Yeah, patch sources, really useful. They apply some patch files. We can see here if you set the type to patch, we can specify a path to a patch file. We can pass custom options to patch. We can have it use git apply or git am instead of the patch command. And strip components, if you're familiar with patches, that most patches will be formatted like, it'll be a diff of a/x.c and b/x.c. And it will just strip this lean component so the patch actually applies. But this basically lets you create some generic patches. I think I might have it in an unpublished Flatpak. Yeah, there's a patch source here. This just passes, this basically means apply this patch, which it looks like this. It applies this patch file. And in cd, we're passing custom options to the patch command that would say cd instead of Flutter directory first. Extra data. This is one of my favorites. Again, allows us to build Flatpaks for proprietary applications that don't allow us to redistribute it. Official VS Code, Unity Hub, grab it, stuff like that. We can see, let me use the VS Code, Unity Hub has the YAML syntax, blah, blah, blah. So we can see an extra data source here. An extra data source literally means that, like all the others, right, they're part of the build process. This one is not. This source is not downloaded until the user installs the application. It's downloaded on their system. That way, you're not redistributing it. You don't run into licensing issues. And you must specify the URL. Again, you must specify the hash. You also have to specify the size in bytes, which you can get with wc-c. So if we were specifying, say let's pretend this is a zip file, wc-c, my archive.zip, this is 4 bytes, so we would use the size 4. This is used so Flatpak can predict how much it needs to download and can give accurate progress to a user. But basically, this file will be downloaded on the user system. Then Flatpak will save the file in /app/extra, and then it'll find a script called apply extra. And I think, yeah, we can see it's called apply extra sh here, but it's actually installed as app/bin/apply extra. Flatpak will run apply extra inside the app extra directory with the extra file saved, and apply extra will do whatever is needed to get this file in a state that can be run. In the Unity Hub, this patches the resources, extracts the Unity Hub app image, moves the files to the extra directory. Again, this is running inside the extra directory. Patches the resources in the VS Code Flatpak. This one's in JSON, but we can see apply extra as a script type. So this script is apply extra that just extracts the deb file and saves VS Code and deletes the leftovers. We can also see the VS Code extra data. And this one uses only arches as well. Let's download a different file for x64 and x86. We can also see the file options. They're actually the same size. I wonder if they're any different. Or, well, the caches are different. But, oh no, they're not. Actually the same. They're like, the size looks so similar. It just threw me off for a moment. And again, we can pass URL, file name. We also need to pass a size to it in bytes. Here's an example. We have type extra data, the file name, URL, hash, size. We have the apply extra scripts that would unzip it, move whatever is needed, clean up the rest. And then in Flatpak Builder, we can also specify cleanup steps. So, right, we're running this, and say in the process of our app, we installed some sort of build tool. Let's say we installed premake. Name premake, build system simple, because one of our modules needed premake. Premake doesn't actually need to be present to run your app. So we can specify a cleanup property on the top level that will have some pass. If the pass is beginning with a slash, it's relative to the installation prefix, in this case /app. So say we installed premake, and it would be something like, this isn't actually how you install premake, but for the sake of demonstration, installs it /app/bin/premake. We can clean up premake binary. Again, this is relative to installation prefix. If it begins with a slash, if it doesn't, like this, it will just delete all files that match this. It deletes at the very end, so all these steps will run, but before it saves it into our final build directory, it will run these cleanup steps. You might clean up include directories, stuff used for building, pkg config files. Those are some common ones you'll see. They can also be specified at the module level. So we can say, like for one app, say this one, auto tools, it does everything automatically. It might install something we don't want. So right here, we'll just be like, oh, let's just cut that out now. Remove whatever helper binary that was automatically installed, but we don't actually need it. Oh, you could also, this is why I mentioned post install, you're not really gonna RM stuff, because it's just cleaner to use cleanup instead. And this is something really interesting. Modules can actually be in different paths. So we might have modules, and as one of the items, instead of specifying this entire object, we just specify a path. X modules.yaml. I believe is it the unofficial Firefox Flatpak that uses this quite a bit? Or is it GIMP? Well, basically, you can say, oh, this is a path to a file. And that file, it would literally have these contents. So say instead of wanting this here, we could take this out, and we could just say abc.yaml, and abc.yaml, dump all this there, fix the indentation, because YAML is indentation sensitive. I didn't do that correctly. There we go. And this is the same as just doing this, except it's a different file. We can do the same thing for sources. So we could say sources, my source.yaml, and in my source.yaml we would have something like, I should be creating all this in a test directory, so I don't litter up this folder. Type, file, type scripts, commands, whatever. Shared modules, this is another really cool concept. Basically, it's based on this, that we can specify modules in different files. Shared modules is a repository. It has a bunch of do I still have that other window open? I should clean this up. It has a bunch of modules to build stuff that you might commonly need, stuff like GTK2, we can add as a submodule. So we would do something like git submodule add Flathub/shared modules. We would add this, and this isn't going to work, it's not a Git repository, but we would do something like that, and then we would be able to use these individual module files, like this one, to build GTK2. And I have an unofficial Ruby Ripper Flatpak that they never merge that does this. You can see there's a shared module submodule right there, and it builds GTK2 through that. Where was I? Let's close this now. Flatpak Builder tools. We're starting to near the end now. I know this is quite a lot, but it's, in my opinion, stuff that's very useful to all know, to know as you build Flatpaks. So during our build, there's no network access, which is good for these reproducible builds. But it's not good if you need network access. Like, say we have a Python application, right? And we might think, oh, as part of our build steps, we need, let's name Python module build system simple. We may need to install Azure, so you may think I could do this. That's not actually going to work because there's no network access. We can add network access by, I forgot the exact option, but we could say, oh, share network for this build step. That's never going to be accepted to FlatHub, which is a Flatpak repository if you weren't familiar with it, so it's not that useful in practice. It doesn't work. So there's a repository called Flatpak Builder tools that contains some scripts that we can use. They will take some sort of lock file or library list, and they'll generate one of these sources files, one of these standalone sources files, or standalone module file that somehow sets it all up. These are some of the ones that are there. .NET generator, I created that one for the .NET stuff. It takes the C# projects and outputs a sources list. npm generator takes package lock, outputs a sources file. Yarn generator takes a log file, outputs a sources file, and so forth. I believe you can see an example in the Ruby Ripper Flatpak of, yeah, here we go, that it runs Ruby Gems generator on our gem file, and it saves it to Flatpak/rubygems.json, and is part of this particular one. You can also add some additional sources to it. So basically, this saves a standalone module that uses bundle to install everything we need. And there should be other examples of that. I think I have a broken one in another repository, not going to look there. In my non-working OSU Flatpak, you can see blah blah blah. Where is this? Where do we build scripts? Oh, here we go. When we run .NET publish, you can see I passed -s source, new get sources, and one of our sources files is osusources.json. That was generated by .NET generator.py. And basically it would be like flatpak.net generator.py, and then we would pass the output file and our C# project file. Now, metadata, this isn't something that I'm going to cover in too much detail because documents it elsewhere, but basically our apps need some metadata, right? Like if we're in, let's close this now, we're in software. Let's see if this actually works today. Everyone who's used software knows it's hit or miss as to whether it actually works. Probably not. Can I at least see something that's installed? Yeah, I can. So basically, see all this metadata, this needs to be specified somewhere. There are 3 different types of metadata we need. All this stuff that we see in, say, the Software Center is given in the AppStream file. And that's also what you see if you go to FlatHub and just open a new window, flathub.org. It's basically the description of your app to basically kind of your marketing shit. Oh, LibreOffice, the productivity suite, has some information about it, links to the website, help, donations, translations. the publisher, the version was last updated. All this stuff is in the AppStream file. And then we have the icon. Of course, icon is decently important. And an XDG desktop file, which is basically how the app is run. You may not be familiar with desktop files. Let me pull up an example. Desktop entry file that has the name of the application. It might have some comments, the command to run, the icon set, stuff like that. And now, normally these will be installed as something like this, the How app. It's just installed as how.desktop. But Flatpak, we don't want to be exporting random desktop files to the user. So it needs to be named your app ID. So if we had com.my.app, it couldn't be named app.desktop. It would have to be named com.my.app.desktop. So there's some nice little properties for our manifest that we can use. Rename desktop file says any desktop files with this name will be renamed automatically. So in this case, my app.desktop will become com.my.app. Let me just copy this here for an example of where it would be used. We would put this at the top level again. So this will rename to com.my.app.desktop. App data file. It will find a file named this and rename it to com.my.app.appdata.xml. Icon, notice there's no extension. That's because there can be a lot of different icon extensions. It'll automatically again rename it to unique app ID. Base apps. This is related to Electron. I'm not going to spend too much time on it. But sometimes multiple apps depend on a common base of some extra modules that aren't in the runtimes. Electron apps, for instance, depend on stuff like libappIndicator, libnotify. None of this is in the base runtimes. So there's a base app that's created, which is basically like a normal app. And it has this stuff, but doesn't have a command or anything, doesn't have metadata. And if I'm building an Electron Flatpak, I would use this as the base, and all this app's modules will be present in my app. I'm not going to spend too much time on that because, again, it only applies to Electron. Just a quick example would be the Discord Flatpak. We can see our base is the Electron base app. It specifies the version, and this basically means that these libraries will be present. So when the Discord Flatpak is built, actually also uses extra data. Nice little example there. But when this Flatpak is built, all these libraries will be available inside. Now, extensions, one of the most powerful concepts in Flatpak. Now, apps need to be extensible in ways, right? We might want a text editor to have different plugins, stuff like NeoVim. HexChat needs to have different plugins. Flatpak handles this by adding extensions, and they can be used for several things. They're super powerful. We can extend the default SDKs, add reusable functionality that can be used by different apps, and again, of course, plugin systems. Extensions are added to add extension mapping, so it would be something like add extensions, and we have a mapping of extension names, their unique app IDs, to some data about them. And basically, this is the extension's name. It will be auto-downloaded if it's not already installed. So when we install my app, Flatpak would automatically install this extension. And then we can, by default, extensions are only available at runtime. We can also make them available for our build by using add build extension instead. And, of course, links to the docs, but there's some interesting options. So basically, remember, this is normally /app, right? Everything in here. When you're building an extension, I don't cover building extensions that much because it's a little bit off topic. But when you build an extension, all this stuff is mounted at a custom mount point. So say this is our extension, right? com.my.app. Do I use .x? Actually, I have a great example here. And let me copy this over into our YAML file. I hate the way it completely screws up the indentation. So this is our extension name, right? Automatically downloaded. This directory is relative to our prefix, which is /app. So this is basically saying mount the extension files, which is all this, right? And an app is only at /app. But for an extension, mounts it at /app/ our directory, which in this case would be /app/lib/x. So all this stuff will be available at this mount point. We can also pass some extra options. We can pass a version of an extension. We can say, oh, we want this the branch, like I mentioned before, version 1.2. You can use this to have like extension protocol versionings and stuff. We can add a path relative to the mount point that will be added to LD library path, useful for shared libraries. Add LD path lib, and anything in here will be added to the app's own LD library path. And then if we don't want the extension to be auto-downloaded, we can say, oh, don't auto-download it. Only if the user manually installs it. And then we can set auto-remove, which says automatically delete it if its parent is deleted. So if we uninstall my app, it will automatically uninstall the extension. Remove after build, only useful if you use it during the build, and it says, oh, this is build only, won't actually be used at runtime. Here's the example that I copied. Mount the contents of our extension at this branch, at /app libx, and it adds the lib directory inside to LD library path. And then, again, this uses an extension. This mount point needs to exist. So if /app libx does not exist, extension simply won't be mounted. So one of your modules, you usually see a build step with build system simple that just creates that directory. And in runtimes, these runtimes can have extensions too, just like apps. And these can be used in the exact same way as apps, so all these use cases apply to everything, which is why they're so powerful. But we can use these to add some extra stuff that's not normally present in the runtime. One of them is the compat extension, which this should be allow equals multilib. But when we mount this extension, this contains some 32-bit libraries that we can use in combination with the multilib to be able to run 32-bit stuff. And then we have this extension, freedesktop.sdk.debug. We can view extensions, Flatpak, show, or Flatpak info-m, in the metadata for, so like, if we look at the platform, we can see a bunch of different extensions, and we can see like, yeah, this is a bunch of extensions that are automatically handled. SDK, I mentioned the debug extension in the slides. If installed, it's automatically mounted inside as debugging symbols for all the core libraries. It's really big. You don't want to install it by default. And compat, there's an example here, so we can see add extensions. The compat extension is mounted at, this will be /app/this directory. The version, in this case, these extensions, their branches all match up with your base runtime. And this basically means that all these libraries, when we install our app, will automatically be downloaded and made available inside. With the debug version, we don't want to auto-download it. That would be very bad, because we don't need it normally. And then we'll have a module that creates the mount point. So what this basically does is says, oh, well, we'll create all these 32-bit libraries. They'll be available at this mount point. So if you have this and in your finish args -- allow equals multi-arch, then you'll be able to run 32-bit applications inside, because you'll have all the libraries and the needed permissions. Do I still have the Flutter Flatpak open? Yeah, you can see that in action here. We have the 32-bit compat extension. It creates the mount points, because Flutter itself has 32-bit binaries, and we have the multi-arch permission. Now, if you're noticing in all of these, right, this mounts an extension with this exact name. Now, if you're making a plugin system, you don't want to have to list the names of every single thing, every single plugin. Oh, we want to enable our Perl plugin, and our Python plugin, and our IRC plugin, because apparently it's Emacs, so it has an operating system inside. that's not that scalable. So we have an option called subdirectories. And let me go up here. Let's look. So we have this option called subdirectories. If it's true, then Flatpak will check, right, for this name. But if this name isn't installed, it'll check for anything installed any extensions installed that begin with this name. If it starts with my app plugin, then Flatpak will automatically mount it to a subdirectory of this directory. So in our example, you should be familiar with most of these options, right? Version 1, this our directory. So Flatpak will find, oh, well, this extension begins with this name. So we'll take it, mount it at a subdirectory of lib/plugins. In this case, app/lib plugins demo. And same thing with this one. So there are two mounts at once as subdirectories of this directory. And then we can also set subdirectory suffix, which instead of mounting right now, it's mounted right here, it would actually mount it to a subdirectory of the extension's own subdirectory. You're almost never going to use that in practice. And another one that we want to specify is no auto download, because we don't want to try and download every single extension when our app is installed. But basically this, I believe HexChat uses this in practice. Let's take a look. FlatHub. Let's go over to HexChat. I don't even want to know how many GitHub notifications I have right now. You can see one of our HexChat plugins, and this is HexChat's module. You can see it adds a plugin, adds the LD path, subdirectories is true, so everything that starts with this, like our Perl plugin, this will be mounted at /app/extensions Perl. You can see here we actually do use the prefix option of build options to set the installation prefix for everything else manually to here. And then we can also specify mergers, which means that any subdirectory of our extension with this name, right? So we might have, for our demo, for this plugin, the sub of this name is demo, here's Cux. So we would say, oh, the data subdirectory of each of these will be merged as one directory under this directory. Useful for plugin loaders. I'm not going to delve that much into it. It's a bit confusing. Just look over at it like 10 times and you'll get the hang of it. Creating extensions, we would, again, we want our branch of extension to match the version. Our app is going to be our runtime. That basically means that we can access all the files inside of our app while the extension's running, because that's how it's going to be run. For our SDK, we're going to, because normally the runtime version uses the SDK version, in this case that's not going to work, so we need to specify the branch manually. We just use a normal SDK. These two options will be explained towards the end. And then in our extensions, we want to install everything to Flatpak Des, which will automatically be set to our destination directory. And here we'll install whatever metadata files so it appears in software, because extensions do appear in GNOME software. Let's see if it works this time. Is this thing just like completely... Oh, no, it works. See, HexChat and... Well, if it... Yeah, it's not working that well right now. But it would show... It's GNOME software, it never works. It would show all the extensions available here because of our AppStream metadata. And it needs to AppStream compose false basically says, oh, don't set up the AppStream metadata automatically, we need to do it manually because it's installed at a custom prefix. And actually, I'll just explain this now. By default, every app, any locale files inside it are separated into a separate extension that's automatically mounted. But if you have an extension itself, it's probably not going to have locale files. So we just set this to false to keep everything a little cleaner. SDK extensions are last main topic, I believe. Yeah. SDK extensions. So we have these subdirectory extensions, right? And one of these is defined on the default SDK itself, right? this already run here, so we can see extension. And this basically means that anything with this prefix will be mounted as subdirectory of usr/lib/sdk. It's not app here because this is a runtime, which is stored at usr. And mounts any extensions with these prefix subdirectories. So any apps using the SDK as their runtime will also have access to these. So if you remember Visual Studio Code, its runtime is the SDK. So we can say run command equals dash com.visual studio code, and we can see all these SDK extensions that I've installed. This one, for instance, is com.org free desktop SDK extension.net. This one is SDK extension Mono 5. This one is Golang. So these are all mounted inside here for when you're using the SDK as your runtime. And that also means during build time, these are accessible, but you have to ask for them. So basically here we can see the example I just showed where we can run the SDK. In my case, I ran Visual Studio Code. All of them are mounted inside. This way I mentioned for the person who asked about calling host commands, that when we're inside Visual Studio Code, if the .NET extension isn't, and actually I believe the latest version automatically adds it to your path. Yes, it does. So basically the .NET SDK special case automatically added to your path, but all these things in the SDK directory are accessible from inside VS Code. In your case, you'd use .NET, again, available now. I added that, I forgot I did. So they're enabled by default. But as a common pattern, if you look inside these, you'll see some shell scripts. And they just do some useful stuff to make them easier to use. So in this case, we might have enable.sh, which usually in the Mono SDK it's called use.sh, I believe, yes. And it'll just set some environment variables to make it easy to use this SDK. So say we source the mono use.sh, now we can run mono. And it just updates the current shell instance to include these environment variables. If you look at the OSU one, you can see here it sources enable.sh, and now for the duration of this build command, .NET is in the path. And anything starting with install will do they can do, let me close this tile. They can do multiple things. If we look in the OpenJDK extension, let's look at OpenJDK 10. You'll see there are some different install scripts. Install.sh, in this case, installs the Java runtime environment for any apps written in Java. Install JDK installs the entire JDK, and these just copy it, because like I said, deduplication. So all these files will automatically be deduplicated. Install JDK installs the whole JDK, install just installs the JRE. I believe the .NET extension has a similar pattern. Install the full SDK, install just that. Oh, what others do I have here? And Monos will, I have no clue what this is doing. I believe this just installs the runtime. There's none here to install the whole SDK. But that's the rough idea. They're just some helper scripts. None of this is mandatory. The Rust extension doesn't actually have any of these, I believe. Rust extension, you would use build options append path / user split SDK Rust stable or whatever it's called /bin. You have to add it manually. None of these helper scripts are there. And you can use them during the build process. So during the build process, we have to set the SDK extensions option to a list of SDK extensions, and then they'll be mounted in the normal directory during the course of the build. Other useful options, I explained these. You can add some different tags to apps. This is kind of useful if you look on some of the no nightly apps as a nightly prefix. It just uses this and will automatically find all desktop files at this prefix. And you can check out FlatHub. for some more examples. Right, tons of Flatpaks here. I mean, we can just, oh look, I have GNOME, blah blah blah. These are a bunch of different stuff. So we can see everything here. And you can use these, I use these, pretty much everything I've learned here. I learned a lot of it from these examples, because back then when I first started, Flatpak didn't have that much documentation. And what documentation it had was not that helpful. Leave this for the end. Okay, we'll leave that question for the end. So, this, tons of examples here. And I actually will go over one example. I created this. It's a really dumb demo application. This is just a little Python app that run, let me see into that directory, host script. We have this just runs a script on the host, basically. And we just open whatever script we want to attach, and it runs it on the host system. And we can see just the source code for it, just basic GTK. But here's the interesting part, where when it uses GTK file chooser native, like I said, this is how you would ensure the portal, the file chooser portal is used. If we use a normal file chooser, GTK tries to draw it from scratch, so we can't use the portal, and we'd have to allow all home access, which is what Electron apps unfortunately have to do. If you look in this, let's look at the, how do we see permissions? I believe it's this, Discord app.discord. We can see it has access to all these, because Electron apps don't use GTK file chooser native. If you love Electron, please star the pull request that has been open for ages that randomly stalled to make it use the native file chooser. We would all be thankful. And this the rest of this is pretty simple. Once we get here, this uses flatpak spawn -- host to have bash call the scripts. And then it sets our status label to return code. And then this is our YAML file. This is our demo script. It just exits with code 12. This is our file, right? We set the app ID. We use GNOME platform here, version 3.32. The GNOME platform versions correspond with GNOME versions themselves. Our command is to run this little application. Our sole source is this file, hostscript.py. The build commands, build system is simple. Build commands just installs it to that location. We have this permission, which again is needed for Flatpak spawn to run host commands. This is needed for X11 sockets to work, and then we do want to use Wayland if possible. I solely disabled it here because I tried using Pipewire screen sharing. It was great, but it was really laggy. And then if we try it out, we can see this file chooser portal is running on our host system. All our recent files are intact. Run our scripts, return code 12, and it printed. This is something to note. When we select a file in the file chooser portal, it mounts it onto this location, run user UID doc, called the documents portal. And this is basically done it basically puts the script there, and then it passes that path as your return value. Not super essential, but something important to note, that you won't actually see the original path it was at. Flatpak will just give you this custom path. This is a fused file system. It's actually a system, the user service, I believe. Is it document portal? Yes. We can see the status of the document portal service. That's what this is. It's just a fused file system. And yeah, this all does what it looks like. Example Flatpaks, check out Flatpub. Getting involved. Try making some Flatpaks. Find an application you like and there's some guideline. Is this still open? Let me close this, and we can open this in a new window. So Main's FlatHub, there are a bunch of guidelines on how to do it. We can see, you want to try and if you're convinced the developers support first. If not, you can do it yourself. Just any apps that you might like that aren't available on FlatHub, feel free to try making some Flatpaks, YAML or JSON syntax. If you're making your own apps, design them with Flatpak in mind. GNOME Builder, it's available as a Flatpak and it's built on top of using Flatpaks. So we can have, this is some playground application I created, and this is built for Flatpaks. Like, it runs your builds inside the Flatpak environment. I believe that you can edit Flatpak options. Yeah, we can automatically say, oh, we want to build this using this runtime. We can automatically specify configure options, change the build environment, and we'll automatically edit this file. It basically sees your Flatpak manifest's build configurations. One catch, you have to use the JSON syntax. So we can use a nice YAML syntax, not supported yet. And docs are great if you want to make some more documentation, something you feel isn't poorly explained in the official documentation. Then feel free to do that and spread the word. Just advertise Flatpak. It's way better than Snaps. Don't want to get too far into that, but look it up. I guarantee it is. So now I'll look at some of these questions that have been posted. If you have any, feel free to ask them now. Any tips for someone who's building an IDE? Look at GNOME Builder. This is basically the quintessential current example of how to do things in a Flatpak environment. The source code written in C, but it's really readable, really well documented. It uses a lot of Flatpak features. It's basically the example of, oh, you want to build apps in a Flatpak or build apps in a container. Supports a lot of these new up-and-coming technologies. I believe there are actually, I want to say, on the new GNOME discourse, there were some questions related to Builder. Just as an example. Next. Oh, maybe it's not on the front page anymore. But there are, like, quite a few. It's basically a great example on doing that. For the VTE terminal, that's going to be a little trickier. Check out how Tilix and Builder do it. Again, Tilix's is buggy, but I'm pretty sure that's on the fault of the GTKD bindings. Nothing for you to have to worry about there. That would be my best advice. Flatpak is available. I did something I unfortunately didn't mention, wish I did. It's available on Freenode. On Freenode, it's #Flatpak. There's also mailing lists, which you can Google. Or, I'll just do it now. It's like, Flatpak mailing list. Yeah, here we go. There's a mailing list. Any particular difficult questions you can ask there. Any questions related to Builder, there's a GNOME Builder IRC. You can probably also ask on the GNOME discourse. Okay, I have to do OARS for some games myself. I never managed to understand it fully. What does the violence tab even mean? So are you talking about the auto generation website, or like if we go, oh well, this isn't gonna find what I want. Worst app ratings. No, this isn't it. Oh, here we go. This, I mean, I've found the explanation to be not that bad. It's filled with dozens of examples about how these would mean. If you have a more specific question about this, I'm not sure if when you looked at it, all these examples were there. I never really used the web. I never write apps really have much network activity, so I've never used this that much. But if you have a more particular question, feel free to add auto generation. Auto generation of what? Okay, just you can explain that a bit further. I'll go on to the next question you asked and then go back to that. How fit my use. Okay, so I'll just cover AppStream data a bit, and that might make it seem a bit more obvious. This AppStream metadata, okay, first off, now it goes in the meta info folder. I don't know. There's reasons behind that. But I've always just used looking at examples to figure out how to do that, because it's not poorly documented, but it's very short on actual practical examples. No, don't go there. I would highly advise, again, look at some other... If you said you're making some games, okay, let me see. Let me look at the gaming category, if this ever loads. You know what? But FlatHub website would probably be faster, because no software is always so slow at this. Let's just look at a game. Let's look at 0AD. Is the... Oh no, the option file is not there. Ah, shoot. Does it say what option file is? I mean, I would highly advise just looking at some of these. I would go to install this right now. But it's... No characters of the story are represented. It's a visual novel with a... If it's... Let's see. I mean, I want to say there's like a community for this somewhere. Oh wow, it's really not obvious, isn't it? Maybe you could file an issue asking about it. That would be my best advice. But if it's all text-based, maybe I would say they would just say to put it to mild or moderate, because mild mostly revolves around depictions or references. Intent is where it actually gets graphic. So if you have something like that, uploading digital. Well, if you have something like that, my best advice, if it's really tricky, ask on the issue tracker. If it seems to kind of fall under one of these, if it's not graphic, it would be labeled as unrealistic or depictions, just non-graphic. Yeah, for some of these, it's going to be really... For some, I would say most likely it would just end up being mild or moderate. If you want more specifics, I would say ask on the issue tracker. App data examples in general, I just always looked at examples. I don't know how... Actually, let's look at the Unity Hub one, because this one was actually accepted into FlatHub. This is kind of... I mean, as far as my understanding goes, when I submitted this, the Unity Flatpak, there's a lot of back and forth about this app data file. One put Bloodshot medium. I mean, if that seems to work, I would say... Oh, reading this comment, if that seems to work for your app data, go for it. If you're not sure, ask an issue. But if it's entirely verbal and non-visual, that seems about right. App data examples, there's a lot of back and forth about what exactly goes into app data and desktop file in an ideal Flatpak. I think some of that discussion is probably also there. Let's see. Internet's failing me right now. Let's see, you can probably see some of this app data discussion towards the end, where it depicts some of the, these are kind of the standards that you'd want to file, or some of the standards that you'd want it to follow. So I would say this is probably a roughly accurate representation of what an app data file would ideally look like. I think Discord's is... This one is probably a little more... Yeah, looking at it, this one is a little more up-to-date. But something like this would be a rough example of what it should look like. Content ratings, of course, that's where the confusion lies. Again, if you have more specific questions about that, probably ask on the issue tracker. But, like, you can say, it has a high DPI icon, releases go here. You can technically put changelogs here. I don't know anyone who actually puts changelogs here. Description, the more interesting ones would be launchable. Apparently you're not supposed to use ID type equals desktop anymore, and then put the desktop file there. You would just want it to be ID and have a separate launchable entry, because app data files now also cover stuff like extensions, which aren't launchable. And then you don't really want categories to be in your app data file. You want it to be in your desktop file. Same thing with the icon, should be in the desktop file, not the app data file. At least for the purposes of Flatpak. Yeah. And that's... I mean, it's going to be a little finicky either way. I would say look at examples. go submit one, and then if they say, oh, you need to tweak this, then just tweak it. That's the best recommendation I can give. And I've just gotta watch this. So basically, if you have any initiatives, like ones to migrate from the old runtime. So, like, do you have, the old runtime initiative. Unfortunately, moving from the 1.6 runtime can be really slow for some really big applications. But I'm not sure if you have something more specific in mind, or if you're just referring to, things that we're trying to modernize. I would say that would be the main one, just moving away from 1.6. Anything you can do to help move away from 1.6 would be great. Yeah, that's probably the number one thing. And yeah, that would probably be the number one thing I would say. Outside of that, app data files, again, they now go in app share meta info instead of app share app data. Outside of that, really, like Flatpak, it moves decently quickly, but hasn't had huge changes. Personally, I changed all my JSON files to YAML files after I implemented YAML support. But that's pretty much all opinion. And on the end of the actual Flatpak developers, both of them are seen as equally supported and effective. Patching AppStream files, I would file a pull request upstream. In general, the policy with stuff like this is you try to upstream it, and then if it's incredibly slow or it's not working out, just say they're like, oh, we don't really want to submit this, we don't want to officially support Flatpak, or the developer just went AWOL for an extended period of time, then you can look at patching it. I wouldn't recommend patching it. For most cases, in general, you try and do that, and if they don't respond, you report to FlatHub, hey, I tried to upstream this but didn't respond, so I'm adding it to the Flatpak. But the general Flatpak policy is try and have as much of it as upstream as possible. The general exception is when upstream doesn't support Flatpak at all, because then some hacks and stuff will be needed, and some of them are truly insane. But if it works, it works. Links to the examples you use. Pretty much, unfortunately, not all of these are things I've actually publicized. Osu, I will finish eventually. Yeah, eventually. Flutter should be, actually, I'll probably publicize that one. I just need to clean up the mess. This one will actually be upstream soon. Stuff like the .NET Flatpak is already on FlatHub. And this is part of the reason I said, oh, you want examples? Go to FlatHub. Because some of them I used are here, right? Like the Unity Flatpak on FlatHub. The .NET extension on FlatHub, both of these I created. They're both examples I used here. And we can see the full example here. Visual Studio Code on FlatHub. So if there was a particular example outside of, I believe the only ones I used really were private, were the Flutter and what was the other one? Oh yeah, the Flutter and Osu examples, and Osu just crashes right now. But outside of those two, everything else. Oh, the host script one. You know what? Yeah, I'll upload after this is over. If you want, I'm not sure if you found this off my Twitter or not. I might put a link to it in the comments if not. But after this, I will upload. This presentation was written entirely open source using Gulp for building. I will forever regret that. Using Markdown to write it and such. And I will also upload this host script example in there. A lot of the stuff that I described is also in the presentation, which will also be uploaded. All these examples and stuff in the actual presentation. Again, that will also be uploaded. And yeah, like I said, host script, I was planning on adding that as part of it, so this will also be uploaded as part of it. I probably won't upload this because it just became a mess over the course of this talk. But pretty much all the stuff that's described here is also has an example in some form in the presentation. Part of the reason the presentation is so long is because I filled it with examples. So if after the fact you're looking at this, you can copy and paste straight from here. And there's also an HTML version of it. So that one probably won't bork the copy pasting parts as much. Let's see. Let's go to YAML syntax. It actually grabs the correct indentation. So yeah, so you would want to copy from the HTML version, which actually grabs the correct indentation. So if there are any more questions, feel free to say them now. I'll just watch in the video until this catches up to where it was, because live stream delays. Okay, so I guess that is all. Last chance. Okay, so thanks for sticking around. This went on a bit longer than I thought. I mean, who would have thought the 60 slides can last 2 hours? But there's certainly a lot of stuff here. A lot of this stuff should be useful. I would definitely say, especially OS repositories, very useful to know, and some of the stuff on extensions. Again, this will be uploaded afterwards on my Twitter. I will put a link to that. Yeah, I'll just put a link to Twitter right now in the comments, so that anyone who... Yeah, I'm just typing that right now. So that anyone who wants the link to the repo when I upload it can just see, and then, yeah. Okay, so I just posted the link in the comments. Yeah, it went on just a little. I will admit, Alex was right there. Definitely. Okay, so that will wrap it up. Thank you for watching. And now if I can figure out how to stop this in OBS Studio, that would be great.